it is not a gas that you are looking for, then you cannot use 22.4. You need to use what? The molarity. So, but now the one that I'm going to teach you today is, hey, we're not going to be at a standard temperature and pressure. It is going to be a gas, but we're going to have to use another equation. And this equation is going to be really important to you. We're not going to learn everything about it. We're just going to learn how to use it in our stoichiometry problems. So if I give you a problem that is not a STP, you can also do it. So the equation is BP equals nRT. It is called the ideal gas law, right? It is called the ideal gas law. Now, V stands for what? V is volume. And is measured, the units are what? Liters. And every time we use it, we're going to stick to the units I'm giving you. P stands for what?
Pressure.
And the units for us are going to be atmospheres. ATM, atmospheres. If I don't give you something in atmospheres, you're going to have to convert it to atmospheres. To work these problems, things have to be in atmospheres.
Are you going to teach us how to do that?
How to convert? So let's say I give you something that is 10 psi, right? Pounds per square inch is another measurement of pressure, is the one that you use in the United States, right? The atmospheric pressure in here in Baton Rouge is 14.7 psi, right? Here at sea level, the atmospheric pressure is that bar that we have, this one, right? This is 14.7 pounds per square inch. That is equal to 1 atmosphere, right? So I'm gonna use that conversion factor. I'm gonna say 14.7 psi are equal to 1 atmosphere. And that's how I will convert it, right? I will use any of those. You see that box? That box will be available. And you have your 14.7 psi and you have your 1 atmosphere in the box. So if I didn't give you that, and I gave you that it was 10 millimeters of mercury, how would you convert it, Kennedy, looking at the box? How many millimeters of mercury are 1 atmosphere? I chose the wrong person because you are too far away. Colleen. No, it's right there. 760
That's millimeters.
of mercury.
Oh, I thought you said milliliters.
No, millimeters. 760 millimeters of mercury are 1 atmosphere. So you will convert, right? Because it has to be in atmosphere. I could give it to you in bars, torr, kilopascals. You just use that.
Will you give us the numbers, like, or will we have to just memorize that?
The conversion factors, they're gonna be in that box, and the box is likely gonna be up there or on a table. So you can get up and see it. Yeah.
So we'll be able to use the box.
You will be able to use the box. I've always had it all my years, my life. I've always had that box, and that's the reason I have them, because I don't necessarily believe in memorizing. You will memorize some of these, undoubtedly, but not yet. When we go to gases, you'll memorize them. But if I give you, your pressure has to be in atmosphere, your volume has to be in liters, what does N stand for?
Moles.
So it's the number of moles. R is a constant. And just like Avogadro's number, it's a number. And we're only gonna use one number, and it's gonna make sure that all our units are right. And R is gonna be 0.08206 liter atmosphere.
I think you told us different.
2, 1.
You said 0.82.
To 1.
My bad.
Yeah, mole Kelvin. It does some, yeah. liter atmosphere mole Kelvin. You will memorize this number, but at the beginning I'll give it to you. Like for stoichiometry, I will give it to you. But if you want to know where this number came from or where the units came from, which are just as important, if you solve for R on that equation, R is equal to BP, is on the other side, over MT, right? MT go to that side. What are the units? Liter atmosphere mole Kelvin, right? So those are the units. If you want to find out what the number for R is, you just replace it. 22.4 liters, 1 atmosphere, 1 mole, 273 Kelvin. 273 is equivalent to 0 degrees C, right? So if you plug those numbers, you'll get this number. So that's where R came from.
273 Kelvin is 0.
Yes. So when you want to convert, and that's what I was going to next, the temperature always has to be in Kelvin. And if I give it to you in degrees C, you have to add 273.15, and then you get Kelvin. Degree C plus 273.15 is Kelvin. It's not degree Kelvin, it's Kelvin. So you will have to convert, because before you plug anything in here, it has to be in those units. It has to be in those units.
Wait, will you repeat without symbol?
Degree C plus 273.15 is Kelvin. So Kelvin is equal to degree C plus 273, which in this case will be 273 because it's, if I make it 0, 0 degrees C is 273.15.
What is the after the 273? If there's like
0.15, you can or cannot have it, I just memorized it like that, but 273 is fine, normally. That is how you convert from degree C to Kelvin.
And what is this formula called? The VP equals RT?
The ideal gas law. Ideal gas law.
is Kelvin a temperature?
Kelvin is temperature. Degree C is temperature. Fahrenheit. Every single morning when I drive here, my dad tells me what's the temperature there, and I have to keep converting. I'm getting good at it. It's between Fahrenheit and degree C, because everything in the rest of the world is Celsius. And everybody here is on Fahrenheit, and it's really confusing. Yes?
Wait, so it equals 273.15.
If you have degree C and you add 273, you get Kelvin.
So if you have like 15 degrees Celsius.
If you have 25 degrees C, how many Kelvin is that? 298. You just add 273 to it. If you have 10 degrees C, how many Kelvin? 283. That's it. You have to be, but you need to remember to convert it. You need to make sure, because all the units have to agree with the units in your R so that they can cancel. How do we use this formula? Well, remember when we were going from volume to number of moles, we used 22.4 and we flipped it? Now, if it's not at a standard temperature and pressure, and I give you volume, you will know the volume, because I'm giving you volume. Pressure and temperature will be given to you. There won't be 0 and whatever, there'll be whatever they want to give you, right? There won't be a standard temperature and pressure. Standard pressure is 1, temperature is 273 Kelvin. You won't have that. So you know those. R you know, right? How do I solve for the number of moles? Number of moles is equal to BP over RT. You plug in everything you know, and you're able to go from volume to number of moles. You just rearrange the equation so that volume is given, and the only thing that you don't know is the number of moles. This is how you do that if we don't have STP. That's what STP, I've always tell people, it's like Merry Christmas. You don't have to do anything. You just plug in the 22.4. But these ones, you actually have to solve it. Yes?
So if it asks you for like temperature,
They won't ask you temperature. The only thing that we're doing with the stoichiometry, volume is given. They ask for number of moles. Number of moles is given. You need to know volume. That's all we're doing. When we get to the gases unit, we'll solve for every single one of those things backwards and forwards, and we'll change them and we'll make them equal to each other. You're gonna know this very well. That's next year. This year, we're not gonna do that. This year, meaning after December. So this before your midterm, we're just going to use these two ways just to get familiar with it, to get a feeling, to get comfortable with the equation, and then we're gonna use it in a million different ways. But that will be later. Now the ideal gas law, that's how you will set it up for that. How would you set it up if I have the number of moles but I wanna go to volume? So BP equals nRT. Now you have the number of moles, you have your R and your T and your P, and you want to know your volume, right? So how do you solve for volume? Volume will be equal to nRT divided by P. And that is how you will go from here to there. It's not a conversion factor per se, it's a formula, right? Did I tell you that some of you were going to put 22.4 when you had a liquid in the test? Did anybody do that? Some people did. Some people did. And I tell you, when I tell you, it's because I've been teaching for a while. When I tell you, do not ever use 22.4 unless you have a gas. I said it from the first day. Why do I say it? Because it happens every year.
Wait, so
And
then how to use 22.4 on the question?
if you were looking for the volume of a gas and you had the number of moles of the gas, yes. If you had a solution like hydrochloric acid or something, and they were asking for the volumes and they gave you the molarity, then you had to use the molarity and the number of moles of your solution, right?
but there was one
Where you had to go from the
where you would use
volume to the
22.4
gas.
You did have to use 22.4 in one, I believe.
Yeah, there
And
was
the one where you found
Yeah.
out how much H2 you got from
the other one. Yeah.
If you're talking about hydrogen, yeah, hydrogen is a gas. Yes, hydrogen gas, 22.4, perfect. Now, if you're talking about hydrochloric acid, no.
How do you do percent yield?
Percent yield is actual over theoretical times 100.
What's
Oh, that was percent error.
No.
Percent error is the difference between how far were you from the real one. So it's the difference between actual and theoretical divided by theoretical. It's always divided by theoretical.
What if I got them switched up?
Somebody did. I think I'm gonna forgive that.
Should the
Because he did, and I was like, really? You got them backwards.
should the percent error and the percent yield add up to be 100?
The percent error and the percent yield, yeah.
With all of it.
You can subtract it from one as well, yeah. So there are many ways. I just always stick to one way because I want to make sure, but there are many ways that we can do what we teach here. There's not just one way. It's just there are many ways to do it. I just like to stick to one way so that everybody does
Are you
it.
gonna be kind of forgiving on this one?
Excuse me?
Are you gonna be kind of forgiving on this one?
Is this one where if we have like the process right?
So I don't want to talk about it in the video. Now, I can tell you a lot of people are making close to 100. A lot, like I've graded at least 8 that are close to 100, at least 8. So a lot of people, there are some people that just went boom down. But most people are, if you understood this, you understood this. I mean, because it was the same thing over and over. There were a couple of things like the last question, it's because we've been talking about the particle diagrams and stuff, but most of the other stuff we've been seeing. Now, let's finish talking about this. So we have the ideal gas law, right? Now, we have question number 2 or 1.
I would add one more question.
Yes.
If it's H2, is that 2 moles of H or is that 1 mole of H2?
That's 1 mole of H2.
So it's molar mass is 1.00.
the molar mass of H2 is 2.00.
Did we learn how to do? I just don't remember learning how to do the one that was like you had to write the equation and.
It's in one of your problems, yes.
I know, but we did it, but I don't know if we learned it.
Of course we did. It's a single displacement reaction. We've done single displacement, we've done double displacement.
AL can't go with CO, so like.
Yeah, I can't now, so you don't
Yeah. And that's one thing that we've done a lot because we've been putting metals in acids like crazy, right? So that's the only one that I thought I could do. Now, let's keep going with this. Question number 2 said, the density of an unknown gas. Ooh, this one is going to joggle your mind depending on how good you are in math. So to some of you, this is gonna be piece of cake. Some others are gonna be, what on earth is this Greek nonsense? So we have BP is equal nRT, right? I'm gonna get 2 formulas out of this one. And it will help you to know them. I tend to use the other 2 formulas. Some of you, at least in the first block, did not like this one bit. So let me show you how. I can substitute BP, I can substitute number of moles for mass over molar mass, RT,
Is this the lab notebook or on the sheet?
in the sheet, but I don't have it yet. I'm still talking, and then we'll do that. So, does that make sense? I can substitute. You've done that in math. Now, the problem is, I want to solve for the molar mass. It's very common that they ask you for the molar mass. So what you have to do is in one step, not 50 million, where people divide and multiply and have this page worth of work. You take the molar mass to the numerator. On the other side, well, it has to be in the numerator, so you have to take it diagonal. MRT are on the right side of the equation. They are opposite to molar mass, so MRT stay.
What about the BP?
What do you mean you take?
And VP comes on this side. So they, I don't know how your math people call it, but cross multipliers. I've heard it called a whole bunch of things. When everything is multiplied and divided in an equation, all you have to do is move things diagonal. That's all you have to do is move things diagonal. If you're solving for something, it better be on the numerator. Don't ever solve on the denominator and then flip. I've seen people do that. Don't do that. You move it diagonal, and these 2 who are there, I don't want them there because my molar mass is there. I move those diagonal. That is how you solve for molar mass. There's another way. If you don't want to do this, this is what one of the blocks preferred, at least for now. If I'm asking for molar mass, you can realize that you can solve for the number of moles, BP over RT, and once you have the number of moles, you know that the moles is mass over molar mass. So once you have that, then you solve for the molar mass. So you can do it either way. You can do it my way, or you can do it the highway. Actually, I've done it both ways, but I tend to prefer that because I like to put everything in the calculator one time. I do know that some of you, at least one person, did not know how to operate a calculator. All the problems were right, all the answers were wrong. So I'm having to go back because all of a sudden the limiting reactant was the wrong one, and then I'm having to rethink what she's thinking to be able to grade it properly. If this was a multiple choice test, you would have failed everything because of calculator errors, not because of not knowing the process. Not in this class, I haven't graded yours. So don't say, hey, I did it or you did it. But learning how to use the calculator is important, yes.
How do you find the molar mass if they're on 2 different sides of the equation?
So the molar mass is on this side, right?
Yeah.
So you move it to over there.
Oh, the molar mass is the MM, and then the
Yes.
moles is the M. Oh, I see.
This mass is M.
Oh, yeah.
So what I did is I use substitution and then I solve for that, right? Or you can solve for the number of moles and then plug it in here and solve for molar mass, right? Now, the other thing that you're gonna need to know how to solve for is density. And this is going to trick your brains a little more.
Wait, is the molar mass dividing all the parts?
Yes, yes. So let me show you the other one.
We have 5 seconds.
So I'm gonna keep you for a minute because I'm gonna finish with density. So the other thing that you have, so just wait a second because I wanna finish density. If I want to solve for density, can you see density here? Right there, mass over volume. Can you solve for density? Can you move everything to the other side?
Yes.
So again, for some of you, this is a piece of cake. So it's molar mass times P, right? Because this is my density, divided by RT, that's equal to density. And obviously I will rewrite it. P molar mass divided by RT. And that's how you can do density. Does this make sense?
Yes, ma'am.
Is this something that is easy for you to do this type of? So